Good evening from NASA's Kennedy Space Center in Florida. You're looking live at Launch Complex 16 at Cape Canaveral Space Force Station in Florida, where Relativity Space is counting down to another launch attempt this evening. You're looking live at their Terran 1 rocket, standing 110 feet tall on Launch Complex 16. That's 33.5 meters in height. The two-stage rocket is currently being loaded with propellants. As you can see, the vapors are quite visible tonight, venting away from the Strongback and the Terran 1 rocket, which is standing in between those four lightning towers, lightning protection masts, surrounding the rocket at Launch Complex 16. Tonight's launch window for Relativity Space runs 3 hours and opens at 10 p.m. Eastern Daylight Time, or 2 a.m. at UTC. That's a little less than an hour and a half away, but we want to bring you live views of the Terran 1 rocket on our live stream as propellant loading continues out at Launch Complex 16. We hope to bring you later in our coverage live views from cameras at the launch pad direct from Relativity Space. Once they provide those views to us, in about an hour's time, we'll have better, closer views of the rocket in the final phase of the countdown. Off to the right, you can see the methane flare stack. Quite a big eruption from that flare stack right now as methane is loading into the two-stage Terran 1 rocket. That flare stack is there much like facilities you see at petroleum refineries around the world. The flare stack there is to burn off any excess methane that's in the area around the launch pad and the fueling system to prevent the risk of an explosion or fire during the launch preparations. We expect to see that flare stack occasionally erupt and become much brighter, just like we saw a moment ago throughout the countdown. This view is about 7.5 miles away from the Terran 1 rocket, looking out toward the northeast at Launch Complex 16 over at Cape Canaveral Space Force Station. This is the closest view we can bring you tonight because the U.S. Space Force, at the request of Relativity Space, is not providing any close-up, on-base media viewing opportunities tonight. Liftoff now 1 hour, 27 minutes away. Weather conditions here are quite favorable for launch tonight. Here's a view at Kennedy Space Center right now, looking live at the crescent moon with the Jupiter in the lower right, setting on the western horizon. A beautiful evening for a launch here on Florida's Space Coast. Clear skies affording us great views of the skies tonight with the crescent moon and Jupiter visible. We hope to see the Terran 1 rocket join this sky later tonight with the launch window opening at 10 p.m. Eastern Time, 2 a.m. UTC. There's a 95% chance of acceptable weather for tonight's 3-hour launch window, according to the latest forecast issued by the 45th Weather Squadron, which is part of the U.S. Space Force unit that oversees range operations here at Cape Canaveral, Florida. T-minus 1 hour, 21 minutes, 5 seconds and counting. Propellant loading is continuing out at Launch Complex 16. The Terran 1 rocket aims to become the first methane-fueled 3D printed rocket to ever achieve orbit tonight if the Relativity test flight goes according to plan. Propellant loading began around 4 hours prior to launch time tonight and should be completed at launch minus 60 minutes. We expect to hear the pre-launch readiness poll from Launch Director Clay Walker in Relativity's control room at 16 minutes prior to liftoff, and then the automated countdown sequence will get underway at T-minus 10 minutes. Right now, there's no technical issues that we're aware of that would prevent a launch tonight. Weather conditions, as I mentioned, also are favorable for liftoff, as again we see the methane flare stack roaring once more, burning off methane at the launch pad. This is a normal operation. If you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That helps us attract a larger audience for our coverage as we count down to this nighttime blast-off of Relativity Space's Terran 1 rocket. T-minus 1 hour, 10 minutes and counting. If you are just joining us, you're continuing to look at a live view of Launch Complex 16, rather, at Cape Canaveral Space Force Station in Florida, where Relativity Space is currently loading methane and liquid oxygen onto the two-stage Terran 1 rocket in advance of its third launch attempt tonight. This is going for the inaugural test flight of this two-stage launch vehicle, which has been in development for a number of years by Relativity Space, a company founded back at the end of 2015 and headquartered in Long Beach, California. That's where this rocket was built, primarily using 3D printing technology at the company's million-square-foot factory in Long Beach. 85% of the Terran 1 rocket by structural mass is produced using 3D printing. Here's a look at some of the specifications and stats associated with the Terran 1 rocket. It's designed and built, as I said, by Relativity Space, a startup company based in Long Beach, California. This Terran 1 rocket is 85% 3D printed by mass. It weighs about 20,000 pounds unfueled. That's about 9 metric tons. So 85% of that mass is produced using 3D printing, including most of the engine components, the tank's primary structure, the nose cone, all produced with additive manufacturing. Some of the components that aren't produced with 3D printing include avionics boxes, computers, harnesses, things of that nature, that making up that remaining 15% of the mass. The Terran 1 rocket is fueled by methane or liquid natural gas. The Aeon engines on the Terran 1 rocket will burn that methane in combination with the cryogenic liquid oxygen for the 8-minute climb into orbit tonight. In this configuration, the Terran 1 stands 110 feet or 33.5 meters tall. It's 7.5 feet or 2.3 meters in diameter. It has a capability of lifting 2,755 pounds or about 1.25 metric tons of payload into a low-altitude orbit or low Earth orbit. At liftoff, the 9 methane-fueled Aeon engines at the bottom of the rocket will produce 207,000 pounds of thrust. As I mentioned, Relativity Space was founded in late 2015 by Tim Ellis and Jordan Noon. They were college classmates at the University of Southern California, and they both worked for other aerospace companies as young engineers at Blue Origin and SpaceX. Ellis, now 32 years old, is the CEO and co-founder of Relativity. The company now has about 1,000 employees and has raised, at last report, $1.3 billion in venture capital and equity funding, including an early investment from billionaire Mark Cuban, the tech entrepreneur and the owner of the Dallas Mavericks basketball team, who provided them with a $500,000 early-stage investment to get off the ground, figuratively speaking, to start the development of their Terran rocket. In 2021, Relativity Space reached a valuation of $4.2 billion. And now, some 7+ years since establishing themselves, Relativity Space is now 1 hour and 6 minutes, if everything goes according to plan, from launching their very first rocket into orbit. This is a test flight. There's no customer payload on board tonight. In fact, there's no payload fairing on this mission either. That's one decision that Relativity made to simplify the test flight. They wanted to focus on the technology needed to get into orbit. One of the main goals of this test flight is to demonstrate that 3D printed structures can withstand the intense vibrations and aerodynamic forces associated with the launch. Engineers will be watching particularly around max Q, about 1:20 seconds into the flight. That's when the peak aerodynamic stresses are exerting themselves on the structure of the Terran 1 rocket as it punches through the atmosphere soon after it exceeds the speed of sound. All the ground testing that Relativity has done to date shows that the structure meets the same safety standard as other rocket hardware made of more traditional metals like aluminum or stainless steel, or in the case of some rockets, carbon fiber. But that hypothesis will be put to the test tonight with the Terran 1 test flight. Relativity's countdown is now approaching the T-minus 1 hour point. According to Relativity's countdown timeline they've provided to us, This is the time at which the propellant loading on the Terran 1 rocket should be concluding. Propellant loading is done relatively early in the countdown for the Terran 1 rocket compared to companies like SpaceX, which use a densified propellant, which is super chilled to even colder than normal cryogenic temperatures. The Terran 1 does not use that densification process. So much like other rockets, such as ULA's Atlas or Delta rocket, the propellant loading is completed well in advance of launch, in this case about an hour before the appointed liftoff time, whereas with SpaceX, propellant loading actually doesn't wrap up until about T-minus 2 minutes. Again, weather conditions here on the space coast of Florida continue to look favorable for launch this evening. Now, T-minus 54 minutes, 5 seconds until the opening of tonight's launch window. Right now, all the word we're getting from Relativity Space is the launch continues to track toward the opening of the window at 10 p.m. Eastern Daylight Time, 2 a.m. UTC. Here's a look at the Terran 1 rocket in this illustration provided to us by Relativity Space. As I mentioned, there's no customer payload on tonight's flight. There's also no payload fairing that will be separating at the top of the rocket. There's that nose cone there will remain attached to the second stage throughout its climb into orbit. There's no deploying payload in there. In fact, Relativity has put a approximately 6-inch wide, 3-pound 3D printed token or coupon into the nose cone that will ride the Terran 1 rocket into orbit. That 3D printed component or element was one of the first structures manufactured by Relativity Space years ago, very early in their development stages, and the company thinks it's appropriate and fitting to have that early stage 3D printed material, that ring, riding a rocket into orbit that is now 85% manufactured by 3D printing technology. The first stage of the Relativity Terran 1 rocket on the left here in this view is powered by 9 Aeon 1 engines. Each of these methane-fueled engines will generate about 23,000 pounds of thrust at sea level. That's 207,000 pounds of thrust, all 9 engines firing at full throttle. Above that, to the right in this view, is the interstage adapter. Inside that interstage is the Aeon 1 vacuum engine. That's the vacuum-optimized Aeon engine on the upper stage, which is located in that volume of the interstage adapter during the initial stages of the climb to orbit. And then above that is the second stage. Both stages have tanks inside them that hold methane fuel and liquid oxygen as the oxidizer. And then at the very top of the 110-foot tall rocket is the nose cone, which again will remain attached to the Terran 1 rocket on tonight's test flight. This is the third launch attempt for this mission. We've been covering this launch now for a few weeks, including the very first launch attempt back on March the 8th. That countdown on March the 8th was stopped at T-minus 70 seconds due to a reading from a sensor indicating that liquid oxygen was too warm on the upper stage of the Terran 1 rocket. So Relativity stood down. They scrubbed that launch attempt to analyze the situation, and then ramped up again for a second launch attempt on Saturday, March the 11th, 3 days later. On that countdown, the clock got just to 0.5 seconds, a half second before liftoff, with the Aeon 1 engines already firing due to a detection of a problem with what Relativity called stage separation automation. This was a preset limit that was in the software logic that was tripped, and that caused the computers that control that final phase of the countdown to call an abort. Relativity engineers reset some of that software, uploaded a new software code, a new section of software code to the computer, recycled the countdown, and tried again just about an hour or two later at the end of the day's launch window. But the countdown on that attempt later in the day on March the 11th ended at T-minus 45 seconds due to a detection, again by the computer automation, of a slightly low pressure in the second stage fuel tank, the methane tank on stage 2. T-minus 50 minutes and counting. We're going to show a replay now of the abort of the launch attempt back on March the 11th that was called off after engine start, just a half second before liftoff. Here you see the Terran 1 rocket in daylight now for this March 11th launch attempt. And there's ignition of the Aeon 1 engines. And the engine shut down there after the computer called the abort, just 0.5 seconds before liftoff. This was the very first launch attempt on March the 11th. Again, as I mentioned, The team rectified that problem and tried again an hour or two later at the end of that day's launch window, but that countdown was cut off at 45 seconds due to a separate issue. And now 11 days later, with a change in the launch window from an afternoon launch window to a late night launch window, Relativity Space is now counting down once more to a third launch attempt for the Terran 1. T-minus 48 minutes, 20 seconds and counting. Again, the weather conditions here at Cape Canaveral look good for launch this evening, with a 95% chance of acceptable weather conditions locally here on Florida's Space Coast. If you're just joining us, my name is Stephen Clark. I'm the editor of Spaceflight Now. I'm providing live updates and commentary on the Relativity Space Terran 1 rocket set to fly to space tonight on its very first test mission. If you haven't done so yet, please consider hitting the thumbs up or the like button here on our YouTube stream. That helps us attract a larger audience for our coverage, as we're now inside of an hour until the opening of tonight's launch window at 10 p.m. Eastern Daylight Time, 2 a.m. UTC. The launch window tonight runs for 3 hours until 1 a.m. Eastern or 5 a.m. UTC. By hitting the thumbs up or the like button, you're helping us again attract more people to our coverage through the YouTube algorithm. So if you could do that, if you haven't done so yet, we'd greatly appreciate that help. Now, the countdown is now holding at T-minus 45 minutes and holding, so this indicates that the launch will not be happening at the opening of tonight's launch window. We'll stand by for an update from Relativity Space. Again, there is a 3-hour launch window tonight for Relativity to work with, so this hold not entirely unexpected. We saw similar holds in the countdowns on the first 2 launch attempts, March 8th and March the 11th. Again, the countdown clock, as you can see in the upper right of our stream, is still holding at T-minus 45 minutes as Relativity Space awaits data from a weather balloon. They're monitoring strong upper-level winds over the spaceport tonight, the company says. No new target launch time yet, but it's clear now that the launch will not be happening at the opening of the window at 10 p.m. Eastern Time. The launch window extends until 1 a.m. Eastern Time, 5 a.m. UTC. While we wait for news from Relativity Space on an updated target launch time and the status of upper-level winds, we want to bring you an interview that we conducted a few weeks ago with Josh Brost. He's the Vice President of Revenue Operations at Relativity Space. He talked about some of the firsts associated with this rocket, including its manufacturing method that Relativity uses, 3D printing, that generates or produces about 85% of the structure of the Relativity Terran 1 rocket by mass. It's also aiming to become the first methane-fueled rocket, or liquid natural gas-fueled rocket, to achieve Earth orbit. Here you see the 9 Aeon engines firing at the base of the first stage of the Terran 1. That first stage is about 7.5 feet or 2.3 meters in diameter, with those 9 engines clustered in a circular formation at the bottom of the booster. The methane-fueled engines produce kind of a telltale blue exhaust flame, and that should be interesting to see how visible or how different the exhaust is at night from a methane-fueled rocket compared to the more distinctive orange glow that we see with rockets that are either solid-fueled or kerosene-fueled in the case of SpaceX's Falcon 9 rocket, which we've become so accustomed to seeing launch here on Florida Space Coast. So I'm eager to see the difference in the exhaust plume between those engines at night. It should even be more visible and more apparent at night than during a day launch. So we want to air a segment of our interview with Josh Brost. Again, he's the Senior Vice President of Revenue Operations at Relativity Space, also a longtime SpaceX engineer earlier in his career. So he has a lot of experience in the commercial launch business. We want to air our chat with him that we had earlier this month, talking about the maiden test flight of the Terran 1 rocket.
And Josh, going into this first flight of the Terran 1, this is a first launch. I know there's always some risk going into a first test flight. Can you set the table for us in terms of the significance of this moment for your company, for Relativity, and also what would define success on this first test flight?
Sure. Yeah, there's a lot to that question, so I'll try to break it down. So first, I'll start with just pointing out no new company has ever had their liquid rocket make it to space on their first attempt. So if everything goes incredibly well and we achieve orbit, on our first launch on Wednesday. That would be a remarkable milestone for us, which we'd be, of course, over the moon excited about. But that isn't what defines success for us. I mean, that would, obviously be the home run, but there are many other things that could happen on launch day that would still be considered very successful for us. I think ultimately, this first launch is really the kind of crowning milestone of many years of work by our entire team to get us to this point. We've developed a brand new manufacturing technology that we've, validated through testing on the ground. We've developed brand new rocket engines, which are, very difficult and complex technical systems that operate right on the edge of what physics says is possible. We've developed brand new, billions of lines of code to operate this whole system, a brand new launch site. And while you can test each of these systems separately on the ground, you really can't do an end-to-end test until you fly. There are just certain things that are different in flight than they are on the ground. And so the flight test is the ultimate validation of that system and of all the learnings that we've had over the last several years. Because there are a number of firsts here potentially on this rocket. It has the chance of being the first liquid natural gas, liquid oxygen rocket to make it to orbit. It is has by far the highest 3D printed content of any rocket in history. We're sitting at about 85% by mass, where I don't think any other rocket has gone past maybe 4%. It's probably less than that. So there's lots of exciting potential firsts here. I think for us as a company, we feel like we've done the testing on the ground to validate that 3D printed structures can survive the launch environment, but obviously demonstrating that in flight will be an important milestone to get through. And as we look at the day of flight operations, you see maximum Q happens partway into stage 1 ascent. That's the point where you get the maximum aerodynamic forces pushing on the rocket. That really is a key validation point for us to show not just to ourselves, but to the world that a 3D printed rocket is really up to the task of taking on those launch environments. And then beyond getting to max Q, it really is about maximizing learning. So it's collecting as much data as possible that we can then use to improve our analytical capabilities on the ground and improve our testing capabilities on the ground as we want to carry on forward to what's next.
One thing about one thing about relativity that always strikes me is you're not only developing a new launch vehicle, which itself is very difficult, but you're also developing an entirely new manufacturing method and system with your 3D printing technology, which I believe is largely from scratch. So talk about the challenges of those dual paths.
Yeah, I mean, rockets are incredibly difficult systems to develop. One of my former colleagues like to use the saying that when the clock gets to 0, a million things can happen and only one of them's good. And that's because rockets are incredibly complex systems that are tightly coupled, where your avionics, your propulsion system, your structures, all these things need to work perfectly in concert to have a rocket ultimately achieve orbit. And so it's adding on to developing the rocket, developing a manufacturing platform is another really challenging thing. Instead of using systems that have been vetted by decades of experience, in some ways we needed to reinvent tool sets to make it not only possible to print a large scale rocket, but to print it reliably. So being able to avoid creating flaws, to detect flaws where they were, to repair flaws where necessary. All of these tools were things that we had to develop ourselves, which added to the complexity of getting to our first launch. But it also makes that first demonstration all the more important and meaningful for us as a company. I think the great thing about 3D printing is it is a technology that we see holds the keys to accelerating the pace of innovation in the industry, and that's why we've been such heavy proponents of it. And demonstrating its capability through launch will be an exciting next step for all of us.
What theoretically and maybe also empirically from your ground testing, what does that information tell you about the strength of these 3D printed structures and tanks compared to carbon fiber or aluminum or stainless steel or something like that?
Yeah, I mean it's a bit of apples and oranges when you compare different materials, but ultimately we're designing the rocket to have the same kind of safety factors and structural margin that you would see in any other system. And so really you design your rocket to be just strong enough to do the mission that it needs, because every bit of additional strength is additional mass that you're carrying to space, instead of taking payload to space. And so from that standpoint, you end up kind of the same as other rockets. And over time we have developed our own alloys to make the printed material both higher performance and more printable, which is part of our very unique tech stack that makes it possible to 3D print an entire, the vast majority of a rocket.
85% by mass created through 3D printing technology.
Yes.
What the other 15%? What types of components aren't quite ready for 3D printing yet?
It's a variety of things. Most of what's not 3D printed are things that are readily purchased off the shelf. There are certainly parts in, what we're really focusing on printing metal structures, or basically metal structures or propulsion components. And so you'll see things like fasteners aren't 3D printed, some of the valves aren't 3D printed. A lot of the avionics system, both the avionics boxes, the computers inside and the harnessing that attaches them aren't 3D printed. And really that's where we were trying to push the envelope to demonstrate how, to really expand what's possible with 3D printing. But at the end of the day, we were also trying to be pragmatic about which parts actually benefit from being 3D printed. And really optimizing for having the best launch system, not for hitting 100% or something.
Is everything the 3D printing? Does it go down into like the turbo machinery of the engines and thrust chamber, things like that, or is that all coming off your 3D printer as well?
So we incorporate a number of different 3D printed technologies, some of which we've developed in house, some of which are come from other companies. But yeah, it's a wide variety of things, from the primary structure to you'll probably have seen pictures online of our engine on a test stand, and the thrust chamber, many of the housings, some other key components are 3D printed. Injectors are a place where 3D printing has been widely adopted and drives tremendous benefits.
That was Josh Brost, the Vice President of Revenue Operations at Relativity Space. I had a chance to talk with Josh a few weeks ago in advance of Relativity's very first launch attempt in early March. He shared with us his thoughts on the maiden test flight of the Terran 1 rocket and the benefits and potential of the 3D printing technology that Relativity Space has developed to build the Terran 1 rocket. Relativity Space is also developing a much larger launch vehicle, twice the height of the Terran 1, that is designed to be fully reusable. Relativity calls that the Terran R, and it too will rely on 3D printing technology for manufacturing. Relativity hopes to have that rocket ready to fly by the end of 2024 at the earliest. It is due to launch also from Launch Complex 16 at Cape Canaveral Space Force Station here in Florida. Relativity's countdown continues to hold at T-minus 45 minutes. The latest update we received from Relativity indicated that the team is monitoring upper-level winds and awaiting an update from weather balloons on the status of the winds aloft. Relativity's countdown continues to hold at T-minus 4 minutes, 45 minutes rather, and holding. This is a hold in order to await updated data on upper-level winds from a weather balloon. The U.S. Space Force's 45th Weather Squadron launches weather balloons throughout every countdown here at the Cape. These weather balloons collect data on wind shears and upper-level wind conditions, wind shears being differences in wind velocity and direction at different altitudes, and that's what is being tracked right now by Relativity Space and the 45th Weather Squadron here at Cape Canaveral Space Force Station. You're looking live at Launch Complex 16 at the Cape, where the Terran 1 rocket should now be fully fueled for launch tonight. That fueling was to be concluded at T-minus 1 hour, and the clock is holding now, as you can see, at 45 minutes and holding. Launch Complex 16 is located on the southern end of the row of active launch pads here on Florida's Space Coast. We've labeled some of the launch pads here on this map. Launch Complex 16 is a pad that was formerly used by the military's Titan and Pershing missile programs. There were 141 launches of Titan and Pershing missiles from Launch Complex 16 back in the early days of the space age. The most recent launch from Launch Complex 16 was back in 1988. So this pad sat dormant for 35 years before Relativity Space is set to resume operations from LC-16 with the Terran 1 rocket. And this map on the northern edge here is Launch Complex 39B and Launch Complex 39A at Kennedy Space Center. 39B is used for NASA's Artemis program and the Space Launch System moon rocket, which took off from Pad 39B back in November. Pad 39A is currently leased by SpaceX for Falcon 9 and Falcon Heavy launches, including crew missions to the International Space Station. So those are the two pads up at Kennedy Space Center. To the south of those pads, crossing over into Cape Canaveral Space Force Station, is Space Launch Complex 41, where ULA launches the Atlas V rocket and will soon be launching the very first test flight of the company's Vulcan rocket. The Vulcan, also a methane-fueled rocket, but the Terran 1 by Relativity has a good chance tonight to become the first methane-fueled rocket in history to achieve Earth orbit, with ULA's Vulcan and SpaceX's Starship waiting in the wings for test flights in the coming weeks or months. Space Launch Complex 40 is used by SpaceX for Falcon 9 missions, primarily commercial flights, securing satellites into orbit. And then south of that is a Space Launch Complex 37, where ULA launches the Delta IV family of rockets. And then Launch Complex 16 is just to the south of that, and LC-16 is between Pad 37 and SpaceX's landing zones 1 and 2 over at the Space Force Station, where the Falcon 9 and Falcon Heavy boosters return to Earth for refurbishment. And then near the far easternmost point of Cape Canaveral is Space Launch Complex 36, where Blue Origin is developing and building a pad for that company's next generation rocket, the New Glenn, a large launch vehicle that could be debuting in the next few years here at Cape Canaveral, Florida. We want to show you an aerial tour of Launch Complex 16. This video was provided to us by Relativity Space, taken last year during the final phase of activation of Launch Complex 16. Some of the work that Relativity Space did at the launch pad included the construction of those 4 lightning towers. Those are the towers around the launch mount there that protect the Terran 1 while it's vertical on the pad from damage from lightning strikes. Off to the left in this view is the hangar. That's where the Terran 1 rocket is integrated before rolling out to the pad and being raised vertical. Here's a closer view of that hangar, this structure just a few hundred feet from the pad at Launch Complex 16. You can also see how close the pad is to the Atlantic coast, the beach there less than a quarter mile away. That enables the Terran 1 rocket to quickly climb off the pad and then be over water. That minimizes any risk of damage to property or personnel during a rocket launch. Relativity Space also installed methane storage tanks as well as liquid oxygen storage tanks at Pad 16. And there you see the video stopped. Great view looking down at the launch mount at Launch Complex 16. Off to the left there is the transporter erector strongback that is currently has used to raise the Terran 1 rocket vertical during launch preparations and is currently visible at the pad vertical, standing next to the Terran 1 rocket as it awaits a potential launch opportunity tonight if these upper level winds permit. Relativity's countdown continues to hold at T-minus 45 minutes as the team continues to evaluate upper level wind data over Cape Canaveral, Florida. Relativity reports that the latest upper level wind data is, quote, trending positively. So that's a good sign that the countdown, and there is the countdown clock resuming at T-minus 45 minutes and counting. So just doing the math, that would suggest a target launch time of 10:38 p.m. Eastern Time, 1:38 a.m. UTC, assuming there are no further adjustments to the clock. Again, the countdown clock now is just past T-minus 43 minutes. So that clock is timed for an apparent target launch time of 10:38 p.m. Eastern Daylight Time, 1:38 a.m. UTC for Relativity's very first Terran 1 rocket. If you're just joining us and you were expecting a launch at the opening of the launch window, there has been a 38-minute delay due to concerns about upper-level winds. However, the upper-level wind conditions are now apparently acceptable for flight, and the countdown has been authorized to proceed, targeting an updated launch time of 10:38 p.m. Eastern Daylight Time, 1:38 a.m. UTC. If you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That really helps us out as we try to attract more viewers for this nighttime launch of Relativity's first methane-fueled Terran 1 rocket. Relativity's countdown now passing inside of 40 minutes until tonight's updated launch time. Again, that target launch time is now 10:38 p.m. Eastern Time, 2:38 a.m. UTC. 36 minutes, 24 seconds and counting. The Terran 1 rocket is just the precursor to what Relativity Space hopes will be much greater things in the years ahead. The Terran 1 is 110 feet tall and is a fully expendable launch vehicle. Relativity's next generation rocket is called the Terran R, which will use uprated Aeon methane-fueled engines evolved from the Aeon 1 engines used on the Terran 1. And the Terran R will be about twice the height of the Terran 1, and instead of being able to haul about a metric ton of payload into orbit, will be capable of carrying about 20 metric tons of payload into low Earth orbit. As you can see here, it looks a lot like SpaceX's Starship and Super Heavy launch vehicle, if you're familiar with that program, but it's about half the height of the Starship, about twice the height of Relativity's Terran 1, and both stages of this Terran R are designed to be fully reusable. We want to air part 2 now of our interview with Josh Brost from a few weeks ago. Brost is a Senior Vice President of Revenue Operations at Relativity Space. Before joining Relativity, Josh was an engineer and manager at SpaceX, so he has a lot of experience in the rocket business. And in our part 2 of our interview with Josh Brost, he talks about the Terran R and talks about the future prospects for the Relativity Space Terran rocket program.
I noticed this mission doesn't have a payload fairing that's going to be separating, no payload separation test as well. Can you just speak a little bit about the decision going into that? Why not test those elements of the vehicle on this mission?
Yeah, I think we were very intentional about trying to get to the pad as fast as we could to maximize the rate of learning. And if you look at history, history would suggest that first rockets by new companies don't make it all the way to orbit. And so you want to make sure we were biting off the technical scope that was most important for our learnings. And you look at how new rockets fail. There's a number of different failure modes that where systems can run into trouble, but those are really where we're focusing our efforts. So it's putting our effort into massive amounts of propulsion testing and the significant amounts of on-ground hardware in the loop kind of avionics testing, and full end-to-end structural testing to make sure that the system has the best chance of getting all the way to orbit that we can get to, and gives us the best chance to collect massive amounts of data that we can then use to improve our systems going forward.
I noticed a tweet, I think earlier today, about the 3D printed structure that's inside the nose cone. Can you tell us a little bit about the significance of that?
Yeah, it's one of the first things that was printed by Relativity, and it's really a great kind of history piece to show, to contrast where we started and where we are. This part was printed several years ago. It's a relatively small metal ring. That was one of the first articles that we as a company managed to print. And the quality is not great, the scale isn't very large, and is riding on top of a rocket that is the majority 3D printed. And so it really kind of bookends where we started and where Terran 1 shows where we are today. And I think it's a great memento to honor the past, and how we got to where we are today.
And before I let you go, can you walk us through some of the testing that you've done out at LC-16 over the last few months, and some of the milestones you've achieved to get to this point and to give you confidence you're ready for flight without doing that final full duration static fire?
Yeah, so the test, we've gone through a massive amount of testing. So, I'll start with the engines, because those are the tests that have the prettiest pictures and that people tend to be drawn to the most. But I'd say each system's testing is critical to the ultimate success. So the engines went through a qualification program, and then each flight engine went through an acceptance test where it was subjected to the full mission duty cycle that it would see in flight as an individual engine. Then the second stage engine was integrated to stage 2. That was put on a test stand at Cenis, and we fired the second stage for its entire mission duty cycle again. Then that stage was shipped on to the Cape to be integrated with stage 1. On the stage 1 path, again, each engine went through an ATP test for mission duration. Then all those engines were integrated into the first stage, and the first stage was hot fired multiple times at the Cape, totaling. Samantha would have to correct or verify the exact number of seconds, but it's something on the order of almost 3 minutes of hot fire testing, at full thrust as an integrated stage. So that's right on the same order, or right about the same amount of duration as the stage one will fire during flight. And then following that, we integrated stage two and went through multiple wet dresses. On launch day, there will actually be one final test, because the way launch works for us, which is similar to how it works for some other vehicles, is our engines light a few seconds before liftoff, and they come up to full power, and the system runs a number of automated checks to make sure each engine is within the acceptable bounds for flight. And only if all those come across as being go for launch does the launch hold down release, and the rocket carries on. If anything's out of family, we will shut it down. So it's really kind of like a final integrated static fire test for launch. At this point in time, we see with all the individual propulsion tests that we've done and stage level tests that we've done, that we've sufficiently mitigated all the major risks going into flight and are ready to go. Is that on the I guess kind of jumped ahead on the structures side, we did a parallel testing path as well, where in development we were doing tons of tests to characterize the as printed material, but then each stage, the inner stage and the nose cone as well, went through independent structural testing to verify that the integrated structures could survive the maximum predicted environments they'll see in flight. We did that on test stands here in Long Beach, where stages were filled with liquid nitrogen to simulate the cryogenic temperatures. And then we used hydraulic actuators to push and pull on them to make sure that they were seeing more stressing environments than they'll see in flight. And then on the avionics side, we've run numerous on-the-ground hardware in the loop tests and hardware out of the loop tests to verify that the avionics and software play together in the ways that we're expecting in flight. Now, all these systems are put together, and we're trying to do the final end-to-end verification in flight itself. That's, again, as I was saying earlier, that's the only way you can actually do a full verification test of a rocket. You ultimately have to fly it, because there's things like the acceleration of the rocket through space that you can't actually simulate on the ground. You can simulate each one of these subsystems, but a rocket accelerating at 4 Gs or so is different than a rocket on the ground being held down on a test stand being tested.
Are you still planning on the $12 million price point for a dedicated Terran 1 flight?
To my knowledge, we have not changed the pricing for Terran 1.
And down the road, once the system is demonstrated, can you talk a little bit about your backlog, how many missions you have on contract and planned for Terran 1?
So we don't specifically call out the Terran 1 versus Terran R manifest at this point in time. And, more directly, we'll be looking to see what we demonstrate on this flight and talking to our customers to really refine our plans going forward. But we'll say our total backlog signed to date is it's over $1.65 billion, and that's spread across 12 customers and spread across Terran 1 and Terran R. So we have a significant backlog that we are very eager to deliver on across a number of customers.
That was Josh Brost, the Vice President of Revenue Operations for Relativity Space. We want to thank him for taking some time to talk with me back earlier this month before the first Terran 1 launch attempt, and it was useful to gain his insights given his experience at SpaceX and his position now as a Vice President at Relativity Space, as this company, part of a new generation of startup launch companies, prepares to fly its first Terran 1 rocket to space tonight from Cape Canaveral Space Force Station. Liftoff time is now 26 minutes 36 seconds away. That is now targeted for 10:38 p.m. Eastern Daylight Time, or 2:38 a.m. UTC. T-minus 25 minutes and counting. And holding. T-minus 25 minutes and holding. So the countdown clock has stopped again at T-minus 25 minutes. These holds are not entirely unexpected, given this is a brand new rocket and a company that's making their first orbital launch attempt. We saw some similar holds in the countdowns back on the first two launch attempts, March the 8th and March the 11th. But with this hold, we're no longer anticipating a launch at 10:38 p.m. Eastern Time, but Relativity still has more than 2 hours of launch window to work with tonight. They can launch as late as 1 a.m. Eastern, 5 a.m. UTC. Relativity Space just provided a brief update to us. The countdown clock is holding due to a boat in a hazard area near the launch site. So the range is monitoring air traffic and marine traffic all around the launch pad, as well as in the downrange flight corridor off to the east of the Cape over the Atlantic Ocean. And apparently a boat, according to Relativity, has veered into that restricted hazard zone. So the countdown clock is now holding while teams work to clear the vessel. Again, the launch window tonight runs until 1 a.m. Eastern Time, 5 a.m. UTC, so plenty of time to work this issue with the boat in the downrange hazard area. This view comes from one of Relativity Space's cameras at Cape Canaveral Space Force Station. They have several different views they're now providing of the Terran 1 rocket on Launch Complex 16. The Space Force does typically have larger range exclusion zones for airspace and marine traffic. For new rockets, such as the Terran 1, those hazard areas tend to shrink over time as rockets gain more flight history and have proven their reliability. But the Space Force does publish, along with the Coast Guard, the maps of the airspace and the marine zones near the coast where airplanes and vessels are restricted for each launch. While the countdown continues holding, we want to bring in a mix of views from our camera position at Cape Canaveral, 7 miles distant, along with a mix of views from Relativity's launch pad cameras much closer to the Terran 1 rocket at Launch Complex 16. You can see the venting from both stages of the Terran 1 rocket and the strong back. The rocket at this point should be fully loaded with methane and kerosene propellants. While we await an update from Relativity on the status of this range violation with a boat in restricted waters, if you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That helps us gain a larger audience through the YouTube algorithm and attract more people to watch this launch, which we hope to see tonight before the end of the window, which is at 1 a.m. Eastern Time, 5 a.m. UTC. So again, please hit the thumbs up or the like button if you haven't done so already. And we're standing by for another update from Relativity, and we'll bring that to you when we have it. My name is Stephen Clark. I'm the editor of Spaceflight Now. I'm reporting live from Kennedy Space Center, just a few miles away from the Terran 1 launch pad at Cape Canaveral Space Force Station. The weather conditions here are ideal for a launch with clear skies and moderate winds this evening. There was a concern earlier in the countdown about upper-level wind conditions, but the latest data from a weather balloon sent aloft indicates that the wind shears in the upper atmosphere are now acceptable for flight. So the only concern right now holding up tonight's launch is this boat in the range exclusion zone, the hazard area, downrange from Cape Canaveral. T-minus 25 minutes and holding. The countdown clock continues to be in a pause here as Relativity Space awaits an update from the range, from the eastern range here at Cape Canaveral Space Force Station, on the status of a boat that's been detected in restricted waters, the launch hazard area off to the east of the Cape. Here's a map of the launch hazard area that was released in recent days by the Space Force and the U.S. Coast Guard, which share responsibility for keeping airplanes and ships out of this area. We often see sweeps by Coast Guard helicopters in the final minutes of the countdown to make sure all vessels are outside of this keep-out zone. This map shows the keep-out zone extending out to the east from Cape Canaveral. The rocket will be heading due east after liftoff, and you can see the corridor there opens up to a wider area of the ocean as you get farther to the east, farther down range from Cape Canaveral. For new rockets launching for the first time, such as Relativity's Terran 1 tonight, the launch hazard area is somewhat larger than it is for rockets that have an established, reliable flight history, such as SpaceX's Falcon 9 or ULA's Workhorse Atlas 5 or Delta 4 rockets. Those have much smaller launch hazard areas, generally speaking, than a new rocket, such as Relativity's Terran 1. But this is the map of the launch hazard area that was released publicly in recent days to mariners who traverse this area regularly, either for commercial or private purposes. But apparently one of these vessels has ventured into this keep-out zone tonight, and the range is working with the Coast Guard to clear that vessel to allow tonight's Relativity launch to proceed here at Cape Canaveral Space Force Station in Florida. We do just have another update from Relativity Space indicating that the team is now targeting an updated launch time of 11:05 p.m. Eastern Daylight Time. That is 3:05 a.m. UTC. No update yet on the boat that is in the keep-out zone, but we apparently, based on the announcement just from Relativity Space moments ago, that boat is either out of the keep-out zone or on its way out of the hazard area. We just heard an update from Clay Walker, Relativity Space's launch director here at Cape Canaveral, confirming the new target launch time of 11:05 p.m. Eastern Daylight Time. That is 3:05 a.m. UTC. The countdown clock we expect to resume in around 5 minutes. While we wait for that countdown clock to resume in about 3.5 minutes, we invite you to support our coverage. There's a couple of ways our loyal listeners and viewers can support our coverage. One of those is by joining our YouTube channel. We have different membership levels available for you to choose from tonight. And depending on which membership level you select, you can gain access to bonus members-only video features that we have produced just for our loyal supporters. Your support by joining our YouTube channel helps us continue to bring you live launch coverage, including these views of the Relativity Space Terran 1 rocket tonight. We were up live tonight well before the start of Relativity's own launch coverage, and we're providing an independent view, unfiltered, of the launch pad, as well as commentary and updates on the status of the countdown. You can also support our coverage by contributing in the Super Chat here on our YouTube stream. Any donations here also help us maintain our coverage, help us attract a larger audience, help us bring you more and more live events as more missions are launched than ever before from here on Florida Space Coast. Your support also helps us continue our 23 years of launch coverage and launch industry coverage on our website at www.spaceflightnow.com. So for those of you who have already become a member or have already contributed in the Super Chat tonight, we appreciate your support. For those who haven't, if you can, please consider doing so. We greatly appreciate your support. Now cutting back to a view from one of Relativity's cameras out at Launch Complex 16. You can see the glow there of the methane flare stack. That's normal. That's part of the safety process to burn off any excess methane in the fueling system and around the launch pad area in the plumbing to make sure there's no risk of any explosion or fire as this flammable fuel is loaded into the Terran 1 rocket. As a matter of fact, at this point in the countdown, the Terran 1 should be fully loaded, both stages, with methane and liquid oxygen propellants. Let's see some of the vapors venting from the strongback as well as the vents on the upper stage and the first stage of the Terran 1. The methane is a cryogenic fuel. Of course, liquid oxygen also a cryogenic oxidizer. Launch Complex 16 is located over at Cape Canaveral Space Force Station, a few miles away from our position at Kennedy Space Center. You can see some of the frost also building up on the outer skin of the Terran 1 rocket as the super cold fuel and oxidizer is inside those tanks ready to propel the Terran 1 off the pad tonight. We hope to see the countdown clock resume in just a matter of moments. And there you have it. The countdown clock is resumed at T-minus 25 minutes and counting. So launch time remains set for 11:05 p.m. Eastern Daylight Time, 3:05 a.m. UTC. T-minus 22 minutes and counting. Relativity Space has confirmed that propellant loading is complete on the Terran 1 rocket, as we suspected. It should have been done at T-minus 60 minutes. So all the propellant tanks on board the Terran 1 have been fully loaded with kerosene and liquid oxygen. The next major milestone in the countdown will be coming up at about T-minus 16 minutes. That's when we expect to hear Launch Director Clay Walker poll his team for a go or no-go to proceed into the terminal countdown sequence. T-minus 20 minutes and counting. T-minus 14 minutes, 15 seconds. We're standing by for the pre-launch readiness poll from Relativity Space's launch director, Clay Walker, at the Launch Control Center here at Cape Canaveral. We'll bring that audio to you when we have it. While we wait for that readiness poll, 13 minutes, 30 seconds to go. If you haven't done so, please hit the thumbs up or the like button here on our YouTube stream. That helps us attract more viewers as we near launch time. Again, this mission, the Relativity Terran 1 rocket, is not carrying a customer payload. It's the very first test flight of Relativity's 3D printed methane-fueled launch vehicle from Cape Canaveral. T-minus 13 minutes and counting.
You're going to pause the clock at T-minus 10 minutes to assess high-level winds. We'll update briefly with a new T0 time once we get new balloon data.
That update from Relativity Space Launch Director Clay Walker. The clock will be holding at T-minus 10 minutes to await some new data on upper-level winds. This has been an issue throughout the countdown tonight. It was reported earlier that winds aloft were strong, and the teams were monitoring those upper-level wind conditions. And then we heard a report later that the winds aloft, based on some new upper-level wind data from weather balloons, were acceptable for flight. But it sounds like Clay Walker, the launch director, says the clock will be stopped at T-minus 10 minutes, or paused rather, at T-minus 10 minutes to await some more data on the upper-level winds. Relativity Space has given us a new updated target launch time of 11:25 p.m. Eastern Daylight Time. So this is another 20-minute delay. We expect the clock to hold here at T-minus 10 minutes for 20 minutes as the team awaits new upper-level wind data. So just to recap, the new target launch time for Relativity's Terran 1 rocket is 11:25 p.m. Eastern Daylight Time, or 3:25 a.m. UTC. The launch window tonight extends until 1 a.m. Eastern Time, or 5 a.m. UTC. Launch Director Clay Walker here at the Control Center at Cape Canaveral just reported that the launch time has been reset for 11:25 p.m. Eastern Time, 3:25 a.m. UTC. That new target launch time has been coordinated with the Eastern Range, the Space Force range team here at the Cape, and the clock has been recycled, as you can see in the upper right, to T-minus 16 minutes and holding. This is where the point in the countdown at which the launch team will be polled by the launch director Clay Walker in a few minutes for their go or no-go readiness to proceed into the final countdown sequence. Tonight's launch will mark the 15th orbital launch attempt from Cape Canaveral or Kennedy Space Center so far this year. All 14 launches to date in 2023 have been performed by SpaceX using Falcon 9 or Falcon Heavy rockets. You can see the SpaceX launches on this graph are noted in blue. You can see the rapidly rising cadence, the increased launch rate from SpaceX over the last 8 to 10 years or so here at the Cape. There were 57 launches here on the east coast of Florida last year. The teams are expecting around 90 or so this year. That was the forecast at the start of 2023. Tonight will be launch number 15 of the year from Florida Space Coast. The Terran 1 rocket is 85% 3D printed by mass. It's produced in a factory at Relativity Space headquarters in Long Beach, California. This B-roll time-lapse video from Relativity shows some of the 3D printer hardware in action at the factory out in California. This shows the buildup of the primary structure and tanks on the first stage of the Terran 1 rocket. You can see here the 3D printer building out the upper stage of the Terran 1. This again is a time-lapse video, obviously, inside the manufacturing chamber at the million-square-foot headquarters for Relativity in Long Beach. This is the nose cone of the Terran 1 rocket being manufactured at Long Beach. This test flight has a nose cone that will remain attached to the upper stage of the Terran 1 during the climb into orbit. It has no payload fairing that will jettison. There's no customer payload on this mission, purely a test flight for Relativity. You can see here different barrel sections of the Terran 1 rocket being assembled at the facility out in California before shipping them to the Cape, to the launch site at Launch Complex 16 for final integration and testing. Some more B-roll from Relativity showing some of the workforce overseeing the operation of the 3D printers. Relativity has said that developing the 3D printing system and this hardware was, in many cases, as much of a challenge as developing the Terran 1 rocket itself. Not only did they have to develop a orbital class launch vehicle, but they had to develop and design and build and activate an entire new line of assembly and 3D printing units out in Long Beach, California. 85% of the roughly 20,000 pound or 9 metric ton structural mass of the Terran 1 rocket is 3D printed. Primarily, the elements that are 3D printed include the tanks, the propellant tanks, the primary structure, the inner stage, the nose cone. Many elements of the Aeon engines on both stages are 3D printed as well. Components like avionics and harnesses and computers are manufactured using more conventional methods for aerospace. Relativity has a proprietary aluminum alloy. That's the material that they 3D print to create their launch vehicle. The clock remains holding at T-minus 16 minutes. We expect to see the clock resume in about 5 minutes or so to target the updated launch time of 11:25 p.m. Eastern Time, 3:25 a.m. UTC. As we await the pre-launch readiness poll from Launch Director Clay Walker, here's a look at some of the major countdown timeline events for the Terran 1. Propellant loading was completed at T-minus 1 hour, so that's been complete for a while now. We're coming up on the readiness poll at T-minus 16 minutes. That will occur in the next few minutes before the clock resumes at 16 minutes and counting. The automated countdown sequence will begin at T-minus 10 minutes, and then following that will be final checks of the Terran 1's flight termination system, as well as chill down of the Aeon 1 engines at the bottom of the first stage. That's a thermal conditioning process that will begin about 8 minutes prior to liftoff. Also in the final 10 minutes of the countdown, the igniters on both stages will be primed for flight. At T-minus 3 minutes, the strong back will begin retracting away from the Terran 1, moving to a position a few degrees away from the launch vehicle to position the umbilical connections in the proper position for the rapid disconnect necessary when the Terran 1 rocket actually leaves the launch pad. At T-minus 70 seconds, the control of the countdown will be passed to the Terran 1's onboard computer, overseeing a final series of checks of launch commit criteria. The engine ignition sequence will begin at T-minus 6 seconds. The 9 Aeon 1 engines will ramp up to full throttle, producing some 207,000 pounds of thrust with all 9 engines firing together. And then assuming those engines are looking good, all of their parameters are acceptable, in a final computer health check, the command will be given to open hold-down restraints to allow the Terran 1 to begin its climb to space. Also in the final 3.5 minutes or so of the flight, of the countdown rather, at about T-minus 3.5 minutes, I should say, there will be a final steering check of the Aeon 1 engines. We may see that live in views from Relativity Space, but here's a look at what that thrust vector control system looks like as the Aeon engines are gimbaled to vector their thrust. This is what's used to steer the rocket and maneuver it onto an easterly trajectory on the way to space this evening. This is video from a ground test here at Cape Canaveral conducted in recent months. We're going to cut over to some views from Relativity Space from their cameras at Launch Complex 16. You can see some of the frost and ice that's accumulated on the outer skin of the first stage, where the methane and liquid oxygen tanks are now full. Above that, with the area with the U.S. flag and the Relativity name, is the inner stage. That's a 3D printed structure that connects the first and second stages of the Terran 1 rocket. Also at the top of that inner stage, those modules that stick out from the circumference of the rocket, those are part of the stage separation system, pneumatic system that will push the stages apart about two and a half minutes into the flight. And then the upper stage will light its single engine and Aeon vacuum engine to continue the climb into orbit. At the very top of the Terran 1 is the nose cone, which will remain affixed to the upper stage. It will not separate on tonight's test flight. See a big glow there from the flame stack, the methane flare stack at pad 16. That's part of the normal process to burn off methane in the fueling system during the countdown. Countdown clock has resumed at T-minus 16 minutes and counting. We haven't heard the pre-launch readiness poll yet from the launch director. Well, here's Launch Director Clay Walker.
Please provide concurrence to proceed in the launch countdown with go, no go. VC, VC go. GC1, GC1 go. GC2, GC2 go. Ground, ground go. AVI, AVI go. FTS, FTS go. RF, RF go. GNC. GNC go. Flight software. Flight software go. Thermal. Thermal go. Prop 1. Prop 1 go. Prop 2. Prop 2 go. Fluids 1. Fluids 1 go. Fluids 2. Fluids 2 go. Loads. Loads is go. Rock. Ranges go. OSM. RC. RC go. Vehicle. Vehicles go. CE. CEs go. LC. LCs go. All parties have reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. A hold is called prior to T-minus 70 seconds. The T-clock will continue to roll until T-minus 70, at which point a hold will automatically be initiated. A hold is not possible after T-minus 70, and any hold call after that will result in a terminal count abort. Should a hold manual be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and RC on primary net.
And you.
That was Launch Director Clay Walker polling his team, and all stations reported they are go for launch at 11:25 p.m. Eastern Daylight Time, 3:25 a.m. UTC, of the Terran 1 rocket on its first test flight from Cape Canaveral, Florida. 13 minutes, 20 seconds until liftoff now. T-minus 12 minutes and counting. After liftoff, the Terran 1 rocket will be heading due east from Cape Canaveral, flying over the Atlantic Ocean, heading for an orbit inclined 28.5 degrees to the equator. This mission will be targeting a very low orbit. This is just a test flight. There's no operational satellite or customer payload on board. This is all a learning experience for Relativity Space. One of the most important things they're eager to see is how the structure, the 3D printed structure of the Terran 1 withstands the vibrations and aerodynamic forces of launch, particularly around a max Q, or maximum aerodynamic pressure, around 1:20 seconds after liftoff. This red line shows the approximate trajectory of the Terran 1 as it heads downrange over the Atlantic from Cape Canaveral, Florida. This is a fully expendable mission. The first stage of the Terran 1 will not be recovered on this flight. Here's a look at the graphic from Relativity Space showing some of the major flight events. After liftoff, with all 9 engines firing, the Terran 1 rocket will begin its pitch down range with the thrust vector control system at T+12 seconds. At 1:20 seconds, as I mentioned, will be max Q, or maximum aerodynamic pressure, on the rocket. Main engine cutoff of the first stage is scheduled 2:40 seconds into the flight. 5 seconds later, the pneumatic stage separation system should push the first stage booster away from the second stage of the Terran 1, and that'll be followed a few moments later by ignition of the single engine on the upper stage for a burn lasting about 5 minutes to accelerate the upper stage and its nose cone, which will remain attached to the rocket, up to orbital velocity. This is about an 8-minute flight sequence if everything goes according to plan from liftoff until orbit insertion of the Terran 1's upper stage. This is the target orbit for tonight's mission. The Relativity Space guidance computer will be targeting an orbit between 124 miles and 130 miles in altitude. That's 200 by 210 kilometers and an inclination of 28.5 degrees to the equator. The countdown now has passed the T-minus 10-minute mark. The final automated countdown sequence now underway, and the final report on upper-level wind data indicates that winds aloft are now acceptable for flight, so no weather constraints right now being discussed by the launch team. Right now, the propellant tanks on the Terran 1 are being topped off and ensured they're entirely full for launch tonight. 9 minutes, 10 seconds. T-minus 8 minutes, 20 seconds. One of the next steps in the countdown will be the chill down of the Aeon engines at the bottom of the first stage of the rocket. This chill down will involve flowing a little bit of liquid oxygen through the engine plumbing to thermally condition those engines for flight. This protects against the risk of thermal shock when those engines light. T-minus 8 minutes and counting. The first stage propellant tanks are being pressurized to flight levels right now with helium. In flight, the propellant tanks will be pressurized, and the pressure inside those tanks will be maintained using what's known as an autogenous pressurization system, using gas converted from the propellants themselves as they're consumed in the engines. That's piped back up into the tanks to maintain pressure in flight. 7 minutes, 30 seconds to go. T-minus 5 minutes, 10 seconds and counting. At this point in the countdown, the engine igniters on both stages should be priming in. This is done by running gaseous oxygen and gaseous hydrogen through the ignition system to prime those engine system igniters for flight. 4 minutes, 45 seconds. Next major milestone will be the beginning of the strongback retraction at Launch Complex 16. Here's a view of the Aeon 1 engines being gimbaled. This is part of the thrust vector control system checkout, making sure the steering system on the first stage is ready for flight tonight. Inside of 3 minutes to liftoff now. One minute, 45 seconds until liftoff now. Strongback has protracted into position a few degrees away from the launch vehicle. "90 seconds to go. Final go for launch has been confirmed from the range, and the transition to the onboard computer has occurred. T-minus 60 seconds. The onboard computer now is in control of the countdown. For the final go from the launch director Clay Walker, ignition of the Aeon 1 engines should be occurring at T-minus 6 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of Terran 1, the first 3D printed rocket. T plus 20 seconds. Terran 1 climbing away from Cape Canaveral. Everything looking good so far. 9 engines producing more than 200,000 pounds of thrust. T plus 1 minute 40 seconds. Everything looking good. Terran 1 has passed max Q, a key milestone on this test flight. No problems reported so far in this test flight of Terran 1. Coming up on T plus 2 minutes now. Terran 1 appearing like a brilliant blue star high in the sky. The blue exhaust, very distinctive from the Aeon 1 engines on the first stage. These methane-fueled engines continuing to perform well so far. About 20 seconds until main engine cutoff and stage separation. Another critical milestone coming soon. There's main engine cutoff. Here's a shot from an onboard camera on the Terran 1. And there's ignition of the upper stage Aeon vacuum engine. We're standing by for an update on the progress of this upper stage engine burn, which should be lasting about 5 minutes. Relativity Space has reported an anomaly with the upper stage of the Terran 1 rocket. We're standing by for more details. The video we saw did show an ignition of the upper stage engine, and then it appeared like the thrust may have terminated. They did still have some live video from the upper stage for some time after that. We were streaming that live. So again, there has been an anomaly with the upper stage, and it appears as if the Terran 1 will not be reaching orbit tonight. The team did get through the entire first stage burn, as well as max Q, or maximum aerodynamic pressure. A key point where the team wanted to test, engineers wanted to verify the structural integrity of this 3D printed rocket. Just to recap, there has been an anomaly, so the Terran 1 rocket will not achieve orbit tonight. Now 7 minutes 40 seconds since the liftoff occurred from pad 16 at Cape Canaveral Space Force Station here in Florida. We did see a brief sign of ignition on the upper stage engine. We saw the onboard camera view at about 3 minutes into the flight show some flame or exhaust from the upper stage engine. And then it appeared, if you were watching our view, that it appeared the engine went silent and went quiet. And we did not see any visible exhaust either from the onboard camera view or in the sky here over Cape Canaveral after that point. So this could be a premature engine shutdown perhaps on the upper stage engine. Relativity reports they're going to provide more information when they have it to release, and they have concluded their live webcast tonight. So with that, the premature shutdown or failure of the second stage will mean the second stage, along with the nose cone of the Terran 1 rocket, will impact in the Atlantic Ocean, likely around this time, either a few minutes ago or a few minutes from now, downrange a few hundred miles east of the Cape. So again, the Terran 1 will not be reaching orbit today. This was a test flight, so although this will be classified as a launch failure in terms of was orbit achieved, Relativity did learn a lot from this mission, and they passed a few of their key milestones, including max Q, or maximum aerodynamic pressure, and stage separation. Now 16 minutes since launch. Just to recap, tonight we saw the first ever launch of Relativity Space's Terran 1 rocket from here at Cape Canaveral Space Force Station in Florida. The flight appeared to go according to plan until a little more than 2 minutes and 45 seconds into the flight, when there was an anomaly that appeared to occur around the time of ignition of the Aeon vacuum engine on the second stage. There appeared to be some sputtering with the upper stage engine as it ran through its ignition sequence, and the velocity meter on Relativity's webcast showed a speed that was decreasing, indicating that there was no thrust being put out or generated by the upper stage engine. A few minutes later, Relativity confirmed in their webcast that there was indeed an anomaly in the upper stage, and that the Terran 1 rocket would not achieve orbit on tonight's test flight. The first 2.5 minutes of the mission went according to plan. There were no problems reported in the live commentary from Relativity Launch Control of any issues with the first stage booster, which was powered by 9 methane-fueled engines. The 3D-printed structure of the booster appeared to stand up to the aerodynamic forces per Relativity's expectations, at least at first glance. The teams will be poring over data from the rocket to make sure that that is indeed the case, and of course they'll be investigating what went wrong on the upper stage before moving forward with a potential return to flight of the Terran 1 sometime in the future. In the more distant future, Relativity plans to debut a much larger rocket called the Terran R that will be fully reusable. The Terran 1 is an expendable vehicle. The Terran R will launch from this very pad that you're looking at now, Launch Complex 16. It's a much larger vehicle, twice the height, about 20 times the lift capability of the Terran 1. And there have been indications from Tim Ellis, the CEO and co-founder of Relativity, that depending on the outcome of tonight's test flight, depending on what the engineers learned, there's going to be a decision whether to continue with the Terran 1 product line and attempt more flights with the Terran 1 for customers potentially in the future, or move on to the Terran R, which is has the potential to be a much bigger revenue earner for Relativity, and a much more capable rocket to lift heavier cargo into space, and also much more cost-effective, being fully reusable. We'll have a wrap-up or recap story later tonight on spaceflightnow.com, trying to give an overview of everything that happened tonight with the test flight that culminated in the upper stage engine failure, at apparent early shutdown of the upper stage engine. That's details of that have yet to be confirmed, but we'll pass that along on social media as well as on our website, www.spaceflightnow, later tonight, or when we receive that information from Relativity Space. Looking ahead to the future launches we'll be covering over the next few days. Coming up on Friday, there will be 2 launches scheduled. One of those, the first in line, will be the launch of a Rocket Lab Electron rocket from down in New Zealand, from Launch Complex 1B, from Rocket Lab's privately owned spaceport on Maya Peninsula on the North Island of New Zealand. This will carry a pair of commercial optical imaging satellites for Black Sky, a company based in Washington State. Rocket Lab plans to attempt to recover the first stage booster of the Electron rocket on this mission at sea with a water splashdown under parachutes, and there will be a boat downrange to fish that rocket booster out of the Pacific Ocean after it splashes down. This is part of Rocket Lab's ongoing experimentation with rocket recovery and eventually reuse of rocket hardware. On Friday morning, later Friday morning, from here on Florida Space Coast, SpaceX's next mission is scheduled to take off at 11:33 a.m. Eastern Time. This will carry a batch of roughly 50 Starlink Internet satellites into orbit on the Starlink 5-5 mission. This launch will depart from Pad 40 at Cape Canaveral Space Force Station. We'll have live coverage on our YouTube channel here at Spaceflight Now for this mission on Friday. That'll be our next planned live broadcast here on YouTube. On Saturday night, U.S. time, or Sunday morning, local time in India, an Indian GSLV Mark III rocket is set to launch with 36 more OneWeb internet satellites. This mission will complete the deployment of OneWeb's first generation constellation for broadband services around the world, pushing OneWeb above the 600 satellite mark. That's how many satellites they need for global broadband service. And then another SpaceX launch is scheduled next week with another batch of Starlink internet satellites. That mission, also from Pad 40 here at Cape Canaveral, is targeted for no earlier than March 29th, next Wednesday, here in Florida. So we'll leave you with one final look at Launch Complex 16, 21 minutes, 45 seconds since we saw the inaugural liftoff of the Terran 1 rocket. It was a spectacular sight. Really interesting to see the distinctive blue flame from the methane-fueled engines. A different appearance than the more bright orange glow that we see from many rockets launching from here at the Cape with kerosene-fueled engines or solid rocket boosters. The first 2.5 minutes of the flight went according to plan. However, there was a failure on the upper stage that prevented the Terran 1 from reaching orbit on this test flight. No payloads were lost. There were no customer satellites on board. This was purely a test flight and learning exercise for Relativity, and the company will be poring over the results of this flight and deciding on a path forward for the Terran program. Now 22 minutes, 45 seconds since launch. Thanks for joining us. My name has been Stephen Clark. I've been providing live commentary tonight from here at Cape Canaveral. I want to thank Stephen Young, our publisher, for video support, showing this view of Pad 16 throughout the evening. Until next time, have a great evening. We'll see you on Friday for the next SpaceX launch.